All right, my young friends, here is the podcast on microscopes. Very quick because this is a review, except for the parts about the electron microscopes. Now, oops, clicking, not working. All right. Remember, compound light microscopes are what we've used so far in class. They're called compound because they have two lenses. That you look through when you're looking through the object. You might look at this and say, but Ms. Coleman, this thing looks like it's got a whole bunch of lenses. True, but you can only look through the lens in the eyepiece, and your eye would go down here through this objective lens and look through that one, and the magnification is combined. So those lenses combine to magnify the image. The eyepiece and these lenses are all called objective lenses, and they have various magnifications, as you already know. Now, the limitations of a compound microscope is that the object you look at must be small, and it has to be mounted on a slide, or else it's not going to work. So you can't look at anything very large. The ocular is the term for the eyepiece, usually a magnification of 10 times. Usually there's a little needle inside so that you can point at objects with it and share them with someone else, show them what you're looking at. Also in this photo is the arm, which you carry it by, and you know that. The revolving nose piece is the part that carries the objective lenses, so this thing will spin to transition from low to medium and high power, at least on ours, the three magnifications. Remember, the objective lenses, these are showing them that have been taken out of the nose piece. Usually they range from about 4 times, which is the low power, that's what our low power is, to a high power. Ours is 40 times. They vary, but that's as high as ours go. The medium power is a 10 times magnification. The low power has the least magnification, but the widest field of view. We are always going to use this first to observe and then work our way up in magnification from there. Coarse focus, the big focusing knob, is what you can use with low power because you can move the stage up and down quite a bit because that objective lens is very short and you're not going to crush the slide up against it. High power, you're seeing the greatest magnification, but the most narrow field of view. Use only after you have observed the organism on low and medium, and only use fine focus. If you observe your specimen on low and medium first, then it will be in the right place in the microscope for you to simply make the switch, the turn to the high power objective lens, and you shouldn't have to do much focusing or moving of the stage at all. It should be set up. That's why we look at low and medium first. Okay? More microscope parts, of course, you know the stage where you put the slide. The diaphragm is a little either a lever or a dial on the side of the stage that controls the amount of light. Coarse focus is the large focus knob. We've already mentioned it. Fine is the small focus knob, and we use that with high power. We never use coarse focus with high power. And of course, the light source and the base are other important parts of the microscope. Now, we haven't done a whole lot with this one yet. This is called a dissecting microscope. Ours look kind of different from this one, but this does have the distinctive part of the two eyepieces, the two oculars. You look at this with two eyes open. It's also called a stereo microscope for that reason. But if you look, you're seeing a whole specimen, a whole sea urchin skeleton, for example, placed on the stage. You could never do that with a compound microscope. So you could look at your hand or whatever. A large specimen can be observed. The limitation, though, is you can't get a very high magnification. This only does a low magnification. I believe our magnification, the highest one on our dissecting microscopes, is about 40 times. Okay? Please remember about field of view. Low magnification, wide field of view. You can see a lot more of the specimen. The specimen's going to appear smaller because it's not very magnified, but if your specimen is moving around a lot, then it's much easier to view it in a wide field of view. You can watch him move. A narrow field of view is going to be a very small area. You're only going to see a part of your specimen. That's good if you want lots of magnification, but if the little critter is moving, he's going to zip in and out of your field of view so fast, it's going to be very difficult, okay, to keep him in there. All right, this is showing you a wide field of view versus a narrow field of view. Okay, same object, old Mr. Lincoln. All right, now, this is important, new material. When we are talking about cells today and the detail that we know about cells, part of that is only possible because we developed some incredibly powerful microscopes called electron microscopes. There are two types, a scanning electron microscope and a transmission one. We're going to talk about the scanning electron microscope first. You can see that it's a big instrument. Of course, this one is probably fairly old. They probably look a little bit different now, but they're not just a microscope that you sit on a desk. It's a big instrument. But you get a very, very large magnification, thousands of times, not just 100, not just 400. Now, if you look at if you're observing something with a scanning electron microscope, you are seeing usually external views of the object. So when you see super magnified pictures of a dust mite or something like that, that is usually done with a scanning electron microscope. The objects observed with that usually have almost a 3D appearance, like you could reach out and touch them. You get this real feeling of texture and being able to touch them. There is a link here that will take you to a site where you can see pictures taken with a scanning electron microscope and see how one works. Honestly, if you hit Google and do scanning electron microscope images, you get just dozens and hundreds of pictures that you might find interesting and some really interesting websites as well. Now, this is a transmission electron microscope, and once again, you see it's a pretty darn enormous structure. Very large magnification, again, thousands of times, even more magnification than with the scanning. So this is the highest magnification microscope available. Now, this one allows us to see the insides of structures. We basically imagine having the world's tiniest slicer. You know, when you go to the grocery store and you go to the deli and you ask for a quarter pound of bologna or whatever it is you like, and they they slice it through that little slicer. Well, imagine slicing a cell, a single cell like that. Then you take a slice and you lay it on a slide or whatever, and you put it into this machine, and you can see the inside of the cell, and you can see all the organelles in incredible detail. So most of what we know about cell structures, cell parts, cell organelles, we know because we have had the ability to use this microscope. The views are more flat, they're more two-dimensional, but nonetheless very, very highly magnified. And again, you can click, if you go to the PowerPoint on our webpage, you can click, use these links and go to various sites, or you can just use Google and see some stuff. All right, I'm going to stop there, take a break, and then we will finish out with talking truly about cells, not just how we can see cells. Okay, so that is it for now. Thanks for watching, and I will catch you in the next podcast. Take it easy.